Alright, welcome to Chapter 1. We're going to cover 1-1 and 1-2. Hopefully we get to 1-3 and 4. Alright, 1-1 is basically covering using variables. It's basically the most basic form. For example, if I have something that says 7 more than n, that's basically just saying n plus 7, okay? And if I have something that says the product of 7 and x, that's just going to be 7 times x, or 7x. There we go, 7x. Alright. The quotient would be division, and you would write it as 7 divided by x, where 7 is the numerator and x is the denominator. And last but not least, the difference of x and 7 would be x minus 7. Alright. So hopefully that makes sense. It's basically just putting words into an actual equation form, and these are called variables. When you don't know a term, it's like a question mark, like what is that in the equation? Like John has 6 apples. What is the difference between John's apples and I don't know, another number of apples? That number that we don't know can be assigned a variable or a letter. You can choose the letter typically. Most of the time when you get to higher levels of math, they will use X or Y or N, pretty much. Alright. That's pretty much that, and then there's different variations of it, and you'll see that in the check yourself. Alright, cool. So that's let's go to 1-2. 1-2 is exponents in order of operations. That's quite simple. For example, I'm gonna work out an example, okay? So if we have 25 minus 8 times 2 plus 3, why is it doing that? Alright, so if you have 25 minus 8 times 2 plus 3 squared. So I don't know who remembers this, but we have something called PEMDAS. PEMDAS is P-E-M-D-A-N-S, okay? PEMDAS is typically remembered by the saying, please excuse my dear Aunt Sally, and there's different variations of it. But P stands for parentheses, E stands for exponents, M stands for multiplication, D stands for division, A stands for addition, and S stands for subtraction, okay? So when you're doing math, you do it in that order. So are there any parentheses? No. Are there any exponents? Yes. So therefore, we can do this part. 3 squared gives us 9, and then we bring everything else down. So we have the plus 2 times 8 and the minus 25. All right? I said it backwards, but you get the point. All right, is there any multiplication? Yes, this is 8 times 2, right? So we have, 25 minus 8 times 2 gives us 16, plus 9. All right, and then you have addition, subtraction, okay? So at this point, I don't remember the exact specific rule for this one, but what I do remember is you go from left to right. Even though it says addition, subtraction, it's more of a addition / subtraction, meaning you just go from left to right, okay? Just go from left to right. Excuse me. So now we have 25 minus 16 gives us 9. And then 9 plus 9 gives us 18, being our final answer. All right. Let's do another example, yeah? If I have, let's do blue. If I have, let's do this. 3 times 6 minus 4 squared divided by 2, okay? All right, parentheses, exponents, multiplication / division, addition / subtraction, okay? So parentheses, I don't see any. Exponents, there's one right there, all right? So 4 squared gives us 16, bring everything else down. Alrighty, now we see multiplication and we see division, so now we just do it from left to right, okay? So now we have 3 times 6 gives us 18 minus 16 divided by 2. Okay, we did the multiplication. Now we do the division. 16 divided by 2 gives us 8. Bring everything else down. 18 minus 8 gives us 10, and that is our final answer. Alrighty. So, please remember PEMDAS. PEMDAS is the key to success, as DJ Khaled would say. Okay? P-E... Why does my screen not work when I get over there? What the heck? P-E-M-D-A-S. This is important. Okay? Alright, going to 1-3. Okay, so 1-3 covers exploring real numbers. And the way I'm going to explain it is kind of the easiest way to explain, I guess. So, excuse me. So, let's do this. I'm going to draw a box. Let's see. Ha, that's cool. I'm going to do a line in that box. Move the line over a little bit. Alright, cool. So, on the left, we will have, I'm going to zoom in a little bit. On the left, we're going to have what are called rational numbers. Alright, rational numbers. And on the right, the opposite of rational would be irrational. So we're going to have irrational numbers. Alright, so left, rational, right, irrational, okay? So within rational numbers, there are things called integers. So for that, I'm going to do a circle. Okay? So within rational numbers, we have what are called integers. Zoom in. Integers, all right. And then within integers, we have whole numbers. Okay, zoom in again. Let's use white. All right, so we have this breakdown, basically, okay? Let's do irrational numbers real quick, because that'll be the easiest. Irrational numbers would be the square root of 10, because there is no square root of 10. Square root of 10 breaks down to be square root of 5 times the square root of 2. This can't be simplified, therefore this is an irrational number, because there is no square root of 10, okay? Let's do this. We have the... Oh, everybody knows this. This is pi. Pi is an irrational number because it doesn't end. It's 3.14 blah 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 forever and ever and ever. Okay. If you have this, the square root of 2 over 3, guess what? There is no square root of 2 over 3. Therefore, you don't have a rational number. This is therefore irrational. Okay. And another example would be if we have 0.10. Come on. I don't like that. 0.1010101. And it keeps going on and on and on. That's irrational, okay? So you got that. Let's go over rational numbers, okay? So rational numbers. What are rational numbers? Rational numbers would be something that can be, it's called, I believe they call it defined, something that is defined. For example, 5 over 8. You can plug 5 over 8 into a calculator, and sadly I don't have a calculator next to me, but 5 into 8 gives you something rational, okay? If you have negative 2 over 3, divide that, you'll get something that's rational. Excuse me, it'll be negative, but yet it'll still be rational, okay? 0.75. 0.75. Rational still, okay? You get the gist. Oh, yes. And then, of course, regular fractions like 1/2 or 37 over 10, 100, excuse me, or something like that, all right? Or a decimal of 0.38 or 31, sorry. Either way, these are all rational numbers. Now, within rational numbers are things called integers. Integers are basically, let me find the actual definition to give to you. Integers are, basically all the numbers you can count on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to infinity. Also, it would encompass 0, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. All right, all the way down to negative infinity. So I'm just gonna write it like this. Integers are the so if we have a number line. Oh wait, it wouldn't make sense to draw with a white pen. So if we have a number line and zeros in the middle, we have -1, 1, 2, -2, 3, and so on. And so on. Okay? So the digits you can count. Bless me. Thank me. I'm welcome. All right. So within integers, we have things called whole numbers. And whole numbers are basically, look at the definition again. All right, whole numbers are basically, zoom in so I can write this, 0 all the way to infinity. Okay, the notation for that, by the way, would be 0 bracket, comma, infinity, parenthesis. Don't worry about that because you won't have to worry about that until geometry, algebra 2, advanced algebra, depending on what you are in, actually. All right. So from this we have, let's see, whole numbers, which would be 0 itself, 3 over 2, I'll take that back, 4 over 2, sorry. Let me make that prettier. See, this is just the coolest mess here, because I can erase, I can draw shapes, I can use different colors. Let's use pink just because we can. Alright, 4 over 2, 6, and the square root of 25. And the square root of 25. Because the square root of 25, we all know, is 5. Cool beans? Cool beans. That covers rational numbers, irrational numbers. It may be good to take a screenshot of this, or just, if you've been taking copious notes, you can copy it into your journal. And of course, it's a video, so you can always just rewind it. All right, cool. That ends this one. I'm going to the next one. All right, now we have 1-4, adding real numbers. Quite simple. We covered in the last one that real numbers, I didn't specify. Real numbers are all of those things. All of those things are real numbers, okay? Oh, yes, okay, cool. So, adding real numbers, I don't know how to, explain this one, but what I am going to do is just give you a couple of examples, and you guys are geniuses, so let's figure it out together, okay? So if we have 3 plus 12, I'm sorry, this is 1-4. Son of a... There we go. All right, so this is 3 plus 12, 15. If we have, let's do a hard one, -27 plus 19, that gives us what, folks? If you said -12, you are correct. Why? Because the way to figure this one out is you have a 27 and you have a 19. Now, the 27 is negative, right? So what we're going to do is we're just going to subtract like regular. Did I say 12? I am on something today. 17 minus 9 is 8. What the heck? 8. Draw an 8. There we go. And 1 and 1, 0 cancel. Therefore, we have -8 is our answer, not -12. Okay. -8 is our correct answer. Excuse me. All right, next one. Why is it doing that? Blue. If we have something like 2 1/4 plus 3 15 over 16ths, what you have to do is get similar denominators before we can add them, okay? Okay. So, let's scroll down a little bit. The way we get this to be like this is we have to multiply this by 4. The denominator by 4. I'm sorry. We multiply the whole fraction by 4 over 4, okay? Actually, that's just one way. And my way isn't the healthiest way to do it, so I'm going to show you the best you can't go wrong way, okay? So what we're going to do is we're going to multiply the denominator by the whole number, add it to the numerator. Denominator multiplied by the whole number, add it to the numerator, okay? 4 times 2 gives us 8. 8 plus 1 is 9 over 4. Plus 16 times 3 is 48. 48 plus 15 gives us 60, 63? 48, 15. That's a 3. Here, the 1, 5, 6. Yeah, it should be 63. 63 over 16. Okay, so now what we have to do is add 4 to add 4. How much of it? We have to get the denominator, like I was saying before, get the denominator to be the same as each other, right? So we're going to multiply by 4 over 4 because that's just a factor of 1. So 4 times 9 gives us what? Hopefully you said 36. And 4 times 4 gives us 16. So now we can add these. Alright, got my trusty calculator because I'm making thousands of videos today and I can't be just wasting time adding because who wants to watch a long video, right? Alright, perfect. So we have 63 plus 36 gives us 99. 99 over 16. I wrote it crooked, or not crooked. I wrote it side by side compared to this way. It's the exact same thing, okay? 99 divided by 16 equals... Let me see. Well, that means 16 goes into 99. I'm sorry. Yeah, that's right. 16 goes into 99. 6 times. We still have the denominator of 16. 16 times 6 gives us 96. Therefore, there should be 3 left over, I believe. Ugh. How did it do that? Okay. So, let's check our answer. You always check your answer in math. The way we do it is we multiply the denominator by the whole number by the numerator, add the whole number to the numerator, and bingo. Keep the same denominator. 16 times 6 equals that, plus 3 equals 99 over 16. Alright, that is our answer. Cool beans? Cool beans. Going to 1 dash